Hi students, welcome to Science Extension and Module 3, the Data, Evidence and Decisions. We've got two more videos before we close this little section in Inquiry Question 2, and this one, video 18, is Establishing Causation. One of the things you need to be able to do is to explain the requirements to establish causation. Causal effects are the finding that change in one variable leads to change in another variable, with the qualifier ceteris paribus, that is, other things being equal. This isn't the butterfly effect, although you may be looking at chaos theory as part of your investigation, but it's more about seeing if we can find a relationship, a causal relationship between the independent variable and the dependent variable, such that we can have confidence that our variation of the independent variable is actually causing a consequent change and perhaps a mathematically calculatable change in the dependent variable. So there are a number of factors that we need to consider when we're trying to establish a causative relationship between two variables. The primary consideration is to ensure that there's no other variables that we may not have taken into account or we may not have controlled appropriately that may be having an impact or perhaps a driving force on the variable that we're particularly interested in. So we have to think about extraneous variables. Is there anything that's actually happening around the room, around the conditions, around the way that we've set up our experiment that may actually be having an impact on our results? Something that we perhaps haven't thought about, but as we reflect on our results, that we now start to realize that maybe it did have an impact. Have we omitted any variables? Have we not taken into account something which is going to be important? Have we possibly not thought about optimum conditions when we're looking at measuring change? If you were doing something like measuring the effect of enzyme function, you'd want to make sure that if you were not looking at varying temperature, for example, that you were looking at other conditions which would lead to optimal function. If, for example, you might be investigating the effect of temperature on activity of an enzyme, you may find that there's a particular pH value that actually ensures that that enzyme is acting at its optimum level. If you haven't thought about that beforehand, maybe you've picked a particular pH value to carry out all of your experiments, and that particular pH is not an optimum for that enzyme, which means it's going to be struggling no matter what temperatures you use. These are important things to think about in terms of the impact that they might have on your results and certainly on your conclusions. Or are there confounding variables? And this is important for us to think about, something that, again, we may not have thought about, we may not be able to control, but it may be having a very important impact on possibly even our independent and our dependent variables. What we need to try and remember is that all three of these different types of variables could imply a causal relationship between two highly correlated variables when there isn't one. And it's important again to just emphasize this difference between correlation, which is the relationship between two variables, and our ability to actually infer causation when we're looking at how we are changing the independent variable and what impact that's having on our dependent variable. According to John Stuart Mills, quoted in Shadish, Cook and Campbell, establishing a causal relationship requires three important criteria. The first of these is temporal precedence, that is, temporal refers to time, and we want to make sure that the cause precedes the effect. So the change we make can only cause the effect if the effect is happening after the change that we've made, that cause relationship between cause and effect. Covariance, that's the second thing we need to think about. Is there an actual relationship between the cause, the variable that we are changing, and the effect, the variable that we are measuring? Is there an actual relationship between these two, or have we not considered something else that might be important? And Mill's third criteria is disqualification of alternate explanations. So, are there confounding variables? Is there something else that we haven't thought about? Did we omit a variable? Is there something that has not been considered that may be having at least as important, if not a more significant impact on our results in changing our dependent variable than the independent variable we are changing that we think is having that effect on the change? So we need to think about the time relationship, the cause preceding the effect. We need to think about covariance, the actual relationship between the two variables that we're specifically interested in. And we also need to make sure that we've removed any other possible explanations that could account for the changes that we are seeing. One of the ways of trying to help you with establishing causation in your experiment is to think about the methodology. The problem with methodology is there's lots of different ways that we can carry out investigations. There are the classical experiments that we can carry out in the science laboratory, so very similar to the ones that you've been carrying out since you're in year 7 and possibly earlier. But what we need to think about when we're carrying out our studies is the conditions that we've set up in order to gather our data. Do we have randomized controlled trials? Are we looking at short-term data, or are we trying to do longitudinal studies? Of course, for the purpose of an HSC, longitudinal study can be a little bit difficult because it is by nature a reduced time frame. Are we thinking about causal modeling? Are we trying to set up a simulation? Are we trying to build models that'll help us explain cause and effect relationships? Are we looking at natural experiments? Are we trying to get hands off and having a look at just the way things would behave in a non-contrived situation? Do we have a quasi-experimental design? Have we kind of been partly involved in manipulating some of the variables, but we're still also trying to see naturally what might happen? Have we thought about instrumental variables analysis? Have we thought about what we're using? We want to make sure that in any situation, in any investigation that we carry out, that we think about our measurement instruments, we think about the relationship between the instruments that we use and the accuracy that we have, but we also want to make sure that the instruments that we're choosing to take our measurements are going to be giving us the data that we need in order to determine causal relationships, and also counterfactual analysis. So we're making sure that we've thought about all of the possible factors that could be impacting on our results. Have we thought about that right from the beginning so that our experimental design, our methodology, is going to lead us in that direction of being able to make genuine, sensible, logical conclusions based on the relationships that we see between the dependent and independent variables, and also in terms of the potential correlation and mathematical relationship between these two variables, two or more variables. Now, one of the things that happens when you start to look at this whole idea of causation and whether or not the fact that two variables seem to be closely linked together in terms of correlation are actually representative of a causal relationship. So you can find lots of these. I've just picked this one out just for example. Google searches for cat memes and automotive recalls for issues with the airbags. Now, if you look at these two graphs, the black and the red, you can see that they are pretty close. And when we put them through our Pearson correlation coefficient, we find that we've got an R value of 0.939, an R squared of 88%, link between these two different variables, and a very significant p-value. But I don't think anyone would suggest that there is a causal relationship between automotive recalls for issues with airbags and Google searches for cat memes. Sometimes, even when the results look good, we have to cast a logical eye over our results to make sure that nothing else is at play and the relationship that we're seeing is a real one. Thanks for watching.